continental drift, an idea before its time. A revolution in the earth sciences began in the early 1900s when a radical proposal was made that the continents drifted about the face of the earth. The development of this revolutionary hypothesis, known as continental drift, is credited to Alfred Wegener, a German scientist. Wegener proposed that a supercontinent, which he named Pangaea, meaning all land, existed over 200 million years ago. In addition, Wegener suggested that this supercontinent began breaking into smaller land masses, which then drifted to their present positions over millions of years. Let's take a look at some of the evidence Wegener cited to support his continental drift hypothesis. First, the fit of the continents. Wegener first suspected that the continents might have been joined when he noticed the similarities between the coastlines on opposite sides of the South Atlantic. Can you see how South America and Africa appear to fit together like pieces of a jigsaw puzzle? Wegener eventually made a crude jigsaw fit of all the continents. Try to fit South America and Africa together in much the same way Wegener did nearly 100 years ago. The fit is better than the supporters of continental drift had expected. Second, fossil evidence. Fossils of the same ancient plants and animals are found today on widely separated continents. For example, fossils of Cinematothus, a reptile that existed around 240 million years ago, have been found in parts of both South America and Africa. In addition, fossils of Lystrosaurus, a reptile that roamed Earth around 240 million years ago, have been found in Africa, India, and Antarctica. Evidence of Glossopteris, a plant which existed around 260 million years ago, appears across all of these continents. Furthermore, fossils of Mesosaurus, a reptile that swam in freshwater lakes and rivers about 260 million years ago, have been discovered in South America and Africa. Why are fossils of Mesosaurus found on both sides of the South Atlantic, but nowhere else in the world? If Mesosaurus had been able to swim well enough to cross the vast South Atlantic, why aren't its remains found in other locations around the globe? How did scientists in the early 1900s explain the existence of identical fossil organisms in places separated by thousands of kilometers of open ocean? Three ideas were proposed to explain the distribution of these fossils. First, rafting. Second, stepping stone islands. And third, land bridges. Could land-dwelling animals have survived the trip across an ocean without a fresh water supply? What happened to these islands and land bridges? Wegener had a better explanation. If the land masses are rearranged into a supercontinent, land animals would have easily migrated across these continents. Third, evidence from rocks. When working a jigsaw puzzle, everyone knows that in addition to the pieces fitting together, the picture must be continuous as well. The picture that must be matched in the continental drift puzzle is represented by rocks of similar type and age, and mountain belts. The Appalachian Mountains are found in eastern North America and disappear off the coast of Newfoundland. Mountains of about the same age and structure are found in the British Isles and Scandinavia. When these landmasses are placed in their pre-drift locations, these ancient mountain chains form a nearly continuous belt. In Wegener's own words, "It is just as if we were to refit the torn pieces of a newspaper by matching their edges and then check whether the lines of print run smoothly across. If they do, there is nothing left but to conclude that the pieces were in fact joined in this way." Fourth, climatic evidence. Earth scientists have learned that about 250 million years ago, vast ice sheets covered portions of Earth's continents. Note that in some of the area that was once covered by ice sheets is found near the equator. Was the entire Earth once as frigid as Antarctica is today? Scientists quickly rejected this idea because at that time, large tropical swamps existed in the northern hemisphere. Today, scientists realize that these ancient ice-covered regions were joined together 250 million years ago and were located near the South Pole. This arrangement of the continents provided ideal conditions for the development of vast ice-covered areas and placed today's northern landmasses nearer the equator. The Great Debate. In 1924, when Wegener's hypothesis was translated into English, French, Spanish, and Russian, Earth scientists began to criticize his ideas. Although correct in principle, Wegener's hypothesis contained some incorrect details. For example, Wegener proposed that as the continents drifted, they broke through the ocean floor much like an icebreaker cuts the ice. Scientists at the time were quick to point out that the ocean floor was too strong to permit passage of the continents. Although Wegener provided evidence to support his hypothesis in 1915, most scientists did not begin to accept continental drift until the late 1960s.